Instead of a yes-no question, suppose we have a how much, how many type question. Suppose that group A had an average of 12.7, let's make it pounds for our unit. B had an average of 10.4 pounds. We knew that the standard deviation in the sample for A was 1.19, and there were 23 individuals. The standard deviation in sample B was 1.05, and there were 15 individuals. The differences in the test. Well, first off, because it's a how much, how many, we're going to be using mu1 and mu2 instead of p1 and p2. 1 and 2, because that's how it's labeled on the calculator, but here it's A and B, so I'll just make a note of the very simple connection between them. 1 in A, 2 in B. It's going to be a t-test. Now, there are two reasons for this. The first reason is that it's S instead of sigma. If we don't know what the standard deviation of the population is, then we have to use the standard deviation of the sample. It's a slightly different distribution, so it's a t-test. The other way to know is I never ask two-sample z-tests. They are used in certain situations, but it tends to be quality control laboratories, so if you don't mind, if I have a two-sample test and it's not a yes-no question, it's going to be a two-sample t-test, just for this class. I look through and I find the keyword is different. I just want to see if group A is different from group B. Now, that keyword is what allows me to say that the alternative hypothesis has as its inequality not equal to. Alpha, in this case, got set to 0.01. I think we're ready to start. On the calculator, stat, tests, 2samp t is line 4. I get to choose between raw data and summary statistics. These are summary statistics, the x bar, the s, and the n. So I'm going to fill them in. x1 is 12.7. S1 is 1.19. N1 is the 23. 10.4 is the x bar sub 2 for the B group. The standard deviation for the B group is 1.05. The number of individuals in the B group was 15. The alternative hypothesis, we have not equal to. Next comes a line which says pooled. Pooled refers to whether or not you use the standard deviations together. Now, that would require some sort of a theoretical argument that group A and group B come from a population that has the same underlying variation. In this course, we're never going to use that argument. It does pop up in certain specialized situations, but not for this class. So for this class, the answer to pooled is always no. And we are ready to calculate. Now, we get a t-value of, and remember, z or t are test statistics, and I like 3 decimal places, 6.258. Now that's rather large. Remember that anything past 2 standard deviations gets you into rare territory. Anything past 5 is very rare. P is going to be 4.7. Well, kind of. If you ever leave, the answer is 4.7. I'm actually going to take off extra points. The reason is that P is a probability. P is always between 0 and 1. 0 means never, 1 means always. So it can't be 4.7. You'll notice that it's 4.7 times 10 to the negative 7. That's less than 0.01, which was my alpha. Therefore, I will reject the null hypothesis. Now, in this case, I've shown that the best explanation is that the two groups are different. So now the question is, how different are they? Since I did reject, I do move on to do a 2-sample t interval. Let's see what happens. Stat, tests, 2samp t int is line 0. I hit enter. All of the data is there. Pooled is still going to be no. Confidence level. Well, if it was a one-tailed test, we would double alpha. If it's a two-tailed test, then we would leave alpha alone. This is a two-tailed test. I would reject if mu1 was much smaller or if mu1 was much larger than mu2. Since this is going to be a two-tailed test, then the confidence interval is going to be 1 minus alpha, 1 minus 0.01. So the confidence interval is going to be the 99% confidence interval. Before I do the result, I'm going to write out the form for the plain English statement based on these being representative samples. I am blank % certain that the mean for group A is blank, then the mean for group B by between blank and blank blanks. So I have some blanks to fill in. The first blank, the degree of certainty, that came from our confidence interval. That would be 99% certain. The other values, well, let's try the calculator. I've put in everything. I switch confidence interval to 0.99 and I calculate. I get 1.29 to 3.31. Well, I'm actually going to match the number of decimal places that I have here. So let's make that 1.3 to 3.3. That's going to be my confidence interval. So those numbers go here, 1.3 and 3.3. Here is going to be the word, either the word higher or lower. And that's going to depend on whether this is positive or negative. But perhaps the simplest way to decide whether you should write higher or lower is to take a look. Is the mean here higher or lower than the mean here? 12.7 is higher. So that's what I'll write here. Last, unit of measurement. And in this case, I did specify that the unit of measurement was pounds. So I put pounds there. Based on these being representative samples, I am 99% certain that the mean for group A is higher than the mean for group B by between 1.3 and 3.3 pounds. We'll do it again with one difference. Instead of giving you summary statistics, I'll give raw data. And I'll also write out the entire form. Here the claim is that the group B mean is higher. That will go into my alternative hypothesis. Now, I do like the summary statistics. When you're given raw data, you have to give back the summary statistics as a report. So I will have X, N, and S, actually X bar, N, and S, for group A and group B, respectively. My null hypothesis, mu1 equals mu2. My alternative hypothesis, mu1 and mu2, I expect the group B mean to be higher. Now 1 goes with A, 2 goes with B. If I expect B to be higher, then I expect A to be lower. So yes, this says higher, but since it's saying that B is higher, you need to put in a less than sign here. I don't see a alpha level, a certainty level mentioned, so I am going to set alpha equal to my default. The default for this class is 0.05. I am going to find t. I'm going to find out what the probability of such a distribution is. I'm going to compare that to alpha, and I'm going to make a judgment with respect to the null hypothesis. Let's take a look. Since I've given raw data, the first step is going to be to enter all of the data. Stat, edit. I've got some data there, let's get rid of it. Up, clear, enter, and I can put the first values in. 5, 6, 8, 8, 9, 10. Now, I'm going to move over to the second list and put in 7, 8, 9, 9, 10, and 12. The lists are the same length long, but they don't have to be. Now, stat, tests. I'm still going to be doing a 2-samp t-test. That's line 4. But this time I'm given raw data, so I switch. List 1 is where I had A. List 2 is where I had B. For frequency, always leave it at 1. For inequality, whatever's in the alternative hypothesis, in this case I switch to less than. Pooled is going to be no for this class, and I'm ready to calculate. I get a t-value of negative 1.449. 3 decimal places. This is your test statistic. I'm getting a probability of 0.089. Now that's greater than 0.05, which was my alpha. Therefore, I'm going to fail to reject the null hypothesis. This is a case where there's no follow-up. Once you say that you haven't found a difference, it doesn't make sense to follow up by asking how large the difference is. But the calculator does have some useful information. It does have x1 bar, that was 7.7. It does have x2 bar, that was 9.2. 1.86, 1.72. For the ends, both had 6 individuals in the sample. Just to show you something though, and because my stat lab often will ask the question this way, I'm going to go stat, test, and I will show you what would happen with the 2samp_t int. Now the input is coming from data. I've got list 1, I have list 2. For confidence level, remember that this was a one-tail test, so I have to double alpha and subtract it from 1. So my confidence level is going to be 0.90. Pooled? No. Calculate? Yes. Now, if there's no difference, if there's no discernible difference, if the difference is not so large that I can't imagine it happening by chance, then I expect here that the confidence interval is going to go from a negative value to a positive value. Whenever you fail to reject, you expect that one number is going to be negative, the other is going to be positive in the 2samp_t int. And notice that we go from negative 3.4 to positive 0.4. And that tells us that it's possible, it's contained within this region, the number 0, since I'm going from negative to positive. So it's possible that the difference is 0, which is the claim that mu1 equals mu2. And that's why we're not rejecting. But when you fail to reject, you typically don't bother with the 2samp_t int.